Surface chemistry is everywhere. In the home, from the kitchen to the bathroom, so many of the products we use every day are related to surface science. From the surfaces of frying pans, soaps, washing powders, even the clothes we wear, all of these have gone through complex chemical processes to make them have the correct surface chemistries. Outdoors, from the ground to the sky, there are examples of surface science in action. It governs why the sky is blue, why and how clouds form, and why rain and snow falls. But what actually is a surface? A surface or interface describes any boundary between two different materials. This could be the boundary between an object and the air, or the boundary between two different objects which are touching. For example, in a cup of tea, one surface is the bit of the tea which touches the air. Or in a chocolate bar, one surface is where the chocolate touches the air, and another is where the caramel touches the chocolate, as they are different materials. But why do we study surfaces? Surface chemistry helps to describe key interactions between different materials. For example, in everyday objects, surface science explains how mixtures can stay mixed and not separate, such as when liquids are mixed with liquids, like in milk. Also, liquids can mix well with solids, like in paint. Some things are made up of gases mixed with solids, which is what marshmallows are made of. Surface chemistry explains how products such as these can stay mixed. Surface chemistry, and how much surface area is on an object, is also really important in making reactions happen faster. For example, we all know that sugar cubes dissolve in water. But have you noticed that sugar dissolves a lot faster when it is broken up into a powder than when it is a full sugar cube? As you can see here, the sugar cube and the powder are added to the water at the same time. After 20 seconds, the powder has completely dissolved, whereas the sugar, which was part of the cube, is still visible. After a minute, both have now completely dissolved. The sugar that was in a powder form reacted much faster than the cube, even though there was the same amount of sugar. This is because, when broken up into a powder, the sugar has more surface area than in the cube. All the smaller sugar pieces added up have more surface area exposed to the water than if they combined into one big piece. The surface is where the dissolving happens, because it is where the sugar touches the water, so the process is faster with smaller pieces. Many scientists use this when doing scientific experiments. They increase the amount of surface to make faster reactions. Catalysts are materials used to make a reaction happen faster, and if more of the surface is exposed, then it will make the process even quicker, like breaking up the sugar cube to make it faster at dissolving. Also, surface science is really important in medicines and in hospitals. When people need hip replacements, implants, or contact lenses, it is very important that the surface between the human body and the foreign object is compatible, so that the patient can stay healthy. Throughout this set of tutorials, we will be learning about surfaces and what scientific research is going on in the field of surface chemistry. Some scientists and companies are able to functionalize surfaces, which means make the surface different to the rest of the material, and we will be looking at various ways in which they can do this, and what these new surfaces can be used for. In this set of tutorials, we will look at how surfaces behave, particularly with regards to water on surfaces. We will also look at how we can make new surfaces on objects, or functionalize surfaces. Then we will look into how these functionalization methods and surface properties are being used in real-life applications and in research and development. The tutorials are split into 3 levels of understanding: beginner for ages 5 to 11, intermediate for ages 11 to 18, and advanced for ages 18 and above, although sometimes videos may be appropriate for more than one age group. Surface chemistry is everywhere. In the home, from the kitchen to the bathroom, so